Ahoy and welcome! My name is Clemens Helm and you are watching Codeship Testing Tuesday number 8. Last week we talked about how test data can help you with your integration tests. This week we'll look at integration tests, unit tests, and how they can help you with your behavior-driven development workflow. Just as a reminder, integration tests test your whole application. So, for example, your user interface, your web application, and your database together. Unit tests only test one specific part or component of your application in isolation. So for example, your user interface or a model. In traditional software development, you write unit tests to develop parts of the software like single classes. When you have enough such tested units, you write an integration test to make sure these parts work together. In behavior-driven development, many developers do it the other way around. They start by describing the behavior of the whole application and continue by specifying the single parts needed for this behavior. This approach is called outside-in development. At Codeship, we also follow this approach because it has several advantages. You stay focused on what you're actually developing for, and that is the user that interacts with the application. You can always be sure that the parts of your application can fit together. When you develop single parts in isolation first and write an integration test for these parts afterwards, it's very likely that these parts don't fit together entirely. This causes additional work for adopting the parts. And you implement exactly what you need. Whereas when you develop parts of software in isolation first, you tend to implement more than your application actually needs. Or you may forget to implement things that the application actually requires. To avoid these problems in traditional software development, you need a detailed specification of the software and its parts first. This is unnecessary in behavior-driven development. In behavior-driven development, the equivalent to integration tests are features. When you develop outside in, you follow this cycle. First, you specify a scenario. You run this scenario and watch it fail. Then you specify the behavior of a component of your application in an example to fix this failure. You run this example and watch it fail. And then you implement the minimum functionality necessary to make the example work. So this is actually the first time that you start writing application code. Once this works, run a scenario again. If it still fails, start another example for a component. Once your scenario works, you can start writing another scenario. Let's try this out. For scenarios, we use Cucumber. I already covered Cucumber in episodes number 3 and number 6. And in some episodes in between. For writing examples for our components, we use RSpec. I will cover RSpec in more detail next Testing Tuesday. Let's say we've got a little application that lets us post our favorite superhero. There's a superhero overview here, and we can add a new superhero on a separate page with their name and description. Unfortunately, at the moment, we can still add superheroes without a name. Let's change that. First, we add a scenario to the posting superheroes feature. I will just paste the step definitions in here. So basically we're visiting the superheroes path, clicking new superhero, create a superhero right afterwards, and then we expect there to be no superheroes, so no element with class superhero, and there should be an error explanation with the error message as content. When we run a scenario now, it fails. So it expected not to find a superhero, but it found one. In Rails, the best way to achieve the desired behavior is to add a validation to the superheroes model. So in the specification of our superheroes model, we make an example that a superhero shouldn't be valid without a name. So it should be invalid and it should contain the error message can't be blank. If we run this example now, it fails. It expects invalid to return true, but it got false. So let's add the validation to the model now. And when we run the example again, it succeeds. When we try to run Cucumber now, it also succeeds. Great, we're done. If there were another failure, we would write more examples for our components until the scenario would succeed. But didn't we put too much effort into testing here? The scenario tests the validation anyway, so why did we need to add the example to the model? Let's look at another example. After a while, we want to enable our users to quickly add superheroes from the overview. We add a scenario that makes this possible. We don't need an additional scenario for the validations now, because this behavior already exists and we only write scenarios for behavior that's not there yet. A few weeks later we decide to delete the old scenario, because we decided to remove the extra page for adding superheroes. This is the moment where our model example saves us. If we hadn't written the example, the validations would now be untested. If someone removed the validation, there wouldn't be any complaints from our test suite. So specifying examples for our components makes changing our application safe. Nowadays web applications tend to change a lot during their lifetime, and so do integration tests. New scenarios are added, others removed, and it's very hard to tell if there is still an integration test covering some functionality. Unit tests make sure that every piece of code remains tested, no matter how our application scenarios change. So when you are developing a web application that will be changed over a few months or years, unit tests will make your life a lot easier. There are several other reasons why unit tests are handy. Unit tests are much faster than integration tests. Integration tests can take a couple of seconds, while unit tests can perform in a few milliseconds. This pays off especially when you're refactoring a class. You can run your unit tests quickly after each little refactoring step to make sure that everything still works. Second, you can find out very easily if and how a piece of code is tested by reading the unit tests. Well-written examples for a class read like a summary of what the class is taking care of. And unit tests let you specify functionality of a component without considering the rest of the system. We will look into this next week in detail. And this is where I have to say goodbye again. It was great to see you, and I'd love to see you again next Testing Tuesday. Next week we'll focus on unit testing. I will show you how to specify components of your application with RSpec and how to use a unit tester's best friends, stubbing and mocking. As usual, I'd be thrilled about your comments. And please remember, always stay shipping.